Unit 1, Lesson 2. Wave motion. Wave motion is a type of periodic motion that you have studied. In this lesson, you will study many subjects related to wave motion, such as the wave motion, types of waves, transverse and longitudinal waves, mechanical and electromagnetic waves, wavelength, amplitude, wave velocity, frequency and periodic time, the wave propagation law. The wave. When some water drops fall on water surface, the propagation of circles on water surface represents a wave motion. When the first domino piece falls, its energy will transfer to the next one that falls down in turn, transferring the energy to the next piece and so on. As you notice, the energy transfer through the domino pieces continues and the pieces never change position in the line. The wave. The wave is the disturbance that propagates and transfers energy in the direction of propagation. In the opposite experiment, when the tuning fork vibrates, the produced energy is transferred in the form of sound waves. The particles of the medium, or air particles, don't move from their original places during transferring sound waves, but the particles vibrate and energy passes through them to the candle flame. The wave motion is the movement resulting from the vibration of the medium particles at a certain moment in a specific direction. Note, the direction of progression of the wave is known as the line of wave propagation. Types of waves. There are two types of waves according to the direction of vibration of medium particles relative to the direction of propagation. Number 1, transverse waves. Number 2, longitudinal waves. Waves also can be classified according to the ability to propagate and transfer energy into number 1, mechanical waves. Number 2, electromagnetic waves. Transverse and longitudinal waves. Transverse waves. Longitudinal waves. On moving the spring coil up and down perpendicular to the axis of the spring coil, a transverse wave is formed. On pushing and pulling the coil from left to right, a longitudinal wave is formed. The direction of the vibration of medium particles is perpendicular to the direction of wave propagation. The direction of the vibration of the medium particles is in the same direction of wave propagation. The transverse wave is formed of crests and troughs. The longitudinal wave is formed of compressions and refractions. Crest is the highest point in a transverse wave with respect to the horizontal. Compression, it is the point of highest density and pressure. is the lowest point in a transverse wave with respect to the horizontal. Refraction is the point of lowest density and pressure. Mechanical and electromagnetic waves. Mechanical waves. They are the waves that need materialistic medium to propagate. Examples: transverse water waves, electromagnetic waves are the waves that don't need any medium to propagate. They can propagate through space. Examples: light waves and radio waves. Note: the velocity of mechanical wave is much slower than that of electromagnetic waves, which propagate in space with a velocity of 3 by 10 to the power 8 meter per second. Wavelength. Wavelength of transverse wave. It is the distance between two crests or troughs. Wavelength of longitudinal wave is the distance between two compressions or rarefactions. Note: the measuring unit of wavelength is the meter or fraction of a meter. Millimeter equals 1 by 10 to the power minus 3 meter. Micrometer equals 1 by 10 to the power minus 6 meter. Nanometer equals 1 by 10 to the power minus 9 meter. Amplitude. Amplitude is the maximum displacement achieved by the particles of the medium away from their points of rest. In the first figure, the amplitude equals 2 meters. In the second figure, the amplitude equals 4 meters. Wave velocity, v. We can determine the wave velocity v by the relation velocity v equals the distance covered by the wave in meters over time in seconds. So v equals d over t. Wave velocity is the distance covered by wave in 1 second. Note: the velocity of any wave is constant as it travels through the same medium. Frequency of wave can be determined by the relation periodic time of the wave t is the time of quant wave, so t equals 1 over f. The wave propagation law. The wave propagation law explains the relation between the wave velocity, its frequency, and wavelength. So, wave velocity equals frequency by wavelength. Problem. Calculate the wavelength in meter for a visible light of frequency 6 by 10 to the power 8 MHz and the velocity 3 by 10 to the power 8 meter per second. Solution. Frequency equals 6 by 10 to the power 8 by 10 to the power 6 equals 6 by 10 to the power 14 Hertz. So the wavelength equals V over F equals 3 by 10 to the power 8 over 6 by 10 to the power 14 equals 5 by 10 to the power minus 7 meter